Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at hierarchical networks. We'll be discussing the three-layer network design, the need to scale the network, borderless switch networks, hierarchy in the borderless switched network, access distribution and core layer functions, and then finally we'll take a look at the role of switch networks. This episode is part of my series on enterprise networking, security, and automation for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Today's networks are growing increasingly more complex. As your company grows, as new technologies arrive, as you find better ways to utilize the resources you have, these networks become more complicated. All of a sudden we go from just having a couple switches and a router on our network to having this full-blown complex network where we have different areas and we have layer 2 switches, layer 3 switches, we have routers. Not only that, then we throw in our data servers, our server farms. We have the business network, we have the remote access network. We're connecting in through DSL, through cable modems, through cellular connections. We even use the plain old telephone system in parts of our network. We have multiple locations. We have all sorts of security we need to implement while still allowing the people access to the data they need to complete their jobs. There's a method to help you make sense of these complex networks. These are the three-layer network design. Here's a sample network. Let's take a look at the networking devices, the intermediary devices, and the end devices on your network. With this three-tier design, we can give you a little bit of structure on how to visualize your network and the roles of each of the devices on your network. What we've done is divided this network into a powerful three-layer network design. The bottom layer right here, this is the access layer. The center layer is our distribution layer. And then the top layer here is our core layer. At the access layer, we have two workgroup switches. These are layer 2 switches, so layer 2 switches here. And these are capable of supporting VLANs, quality of service, and power over Ethernet. Here we have power over Ethernet supplying power to this access point, and we also have power over Ethernet supplying power to this voice over IP phone. The voice over IP phone also needs quality of service to provide a decent quality for a voice conversation over your network. There are multiple VLANs that the access layer supports. Here we have this blue square. This is the guest network. Then we have several user VLANs. The yellow represents user VLAN 1. Green represents user VLAN 2. Not only can they be brought off of one workgroup switch, they can also be brought off of all of your access workgroup switches. So here we have user 1. Here we have user 2. User VLAN 2. Notice down here that the user here on PC 11, they connected in a hub to support extra devices. Now they have not only PC 11, but then they have another PC they brought in. This type of activity could be considered a violation of network policy. And port security could be used to shut down this connection, this port here, to the hub and these connected devices. At the distribution layer, we have two multi-layer switches. So both of these are multi-layer switches. These are layer 3 switches that are not only capable of switching, but can also provide routing, static routes, and dynamic routing. These distribution switches can also apply network policies through ACLs, access control lists. At the core layer, we have another multi-layer switch, and That switch's responsibility is to forward packets as fast as possible to the edge router. The Edge 1 router is capable of network address translation, as well as being an edge firewall, so firewall, to the internet. And in this example, the Edge 1 router connects into a cable modem that connects into your ISP that connects you across your network to your destination. As time goes on, your organization relies on your network infrastructure more and more to provide access to mission critical services. You are running all of these different programs, all of these different databases, applications to make your company go. If people don't have access to these applications and services, your company can't make money. So these are mission critical. If they're not working, your company's not making money. As your organization evolves, it requires networks that can scale. So your network needs to scale, but it also needs to support converged network traffic. When we look at your network, you have voice on there, you have video on there, you have data on there, and you can be running other things on there. To your network, it just looks like IP packets going across there. IP necessarily doesn't care what you are transferring across there, so all of this data is converged into that one protocol. We also need to support these critical applications, so you have to understand the software, how to access this information on your network and provide access to those people who need it. We have diverse business needs that you need to support on your network. You have mobile users, you have people that are in the office. They have to use the printer, have to have access to different file shares. Very diverse business needs across the different users on your network to allow them to complete their job successfully. And with all of this going on, wouldn't it be nice where you don't have to go around to each individual device and configure them? You could centralize the administrative control and do it from one area. And sometimes it's overlooked, sometimes it's just assumed, but be aware as you're designing your network, figure out how you're going to administer all of those devices, all those technologies, all those protocols. And designing a network, you have to think, okay, the network could be any size. You need to figure out what size your company is. It could be a small network that has a single switch on it, and it can be to a very large network that supports thousands, if not thousands, tens of thousands, even hundreds of thousands of connections on your network. How do you support that? How do you design for that? The Borderless switch network is a network architecture that can connect anyone, anywhere, anytime on any device, and it can be done securely, reliably, and seamlessly. So anywhere or anyone, anywhere, anytime on any device, this is the access to all that data, but you need to make sure we do it securely. Only the right people getting into the right data, reliably, that when they need that data, they can get it, and seamlessly. It's the same data, and we're not held up by a lot of roadblocks to get to that data. Borderless switch networks provide a framework here. It's a framework to unify your wired and wireless access. It's built on a hierarchical infrastructure of hardware that should be resilient and scalable. Now, this borderless switch networks are hierarchical, modular, resilient, and flexible. I hope you're liking this episode on hierarchical networks. If you have the time, please leave a comment and let me know what you think about hierarchical networks. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. Hierarchical networks use a tiered design of typically 3 layers: the access layer, distribution layer, and the core layer, with each one of those layers performing a defined role in your campus network. There are 2 types of these hierarchical designs. One is a 3-tiered network. That's where each one of these layers, the core network, the distribution, and the access layer, they are all separate. They're all doing their own functions. This is for a bigger company. Where we have the 2-tiered network. What we do in the 2-tiered network is the core and the distribution layer, they're combined. So this is typically for a smaller company. That access layer is still separate, but we've combined the core and distribution here in our 2-layer design. As we look at each one of these layers, the access layer, the distribution layer, the core layer, traditionally they've had well-defined functions that happen at each one of these layers. But as time has progressed, as new technologies have arrived, as we found new and ingenious ways to apply existing technologies, sometimes the line between these 3 layers are blurred a little bit. And devices can maybe that used to be at the access layer now at the distribution, or distribution at the access layer. The core network, this is your network backbone. This is high speed right here. This is as fast as you can get your data to travel. And a lot of times we are looking at connecting building to building at this point. Not a whole lot of other function happens on your core devices besides transferring data from one location to another. Typically, it's relatively close, within a few miles, usually. Building to building on your campus is a lot of times where we'll see this high-speed network connection. Then we have our distribution layer. Our distribution layer is where a lot of the processing happens. Here at the distribution layer, we can implement routing, we can implement QoS, and we can put security in there. We can look at, these are layer 3 switches, and we can do the routing. We get VLANs. There's lots of VLANs typically in our network. Here at layer 3 is where we route between those VLANs. We also route between the different parts of our network, between one building and another building. At the distribution layer, we can look at putting access control lists in there, allowing only certain traffic through. Once again, standard access control lists, extended access control lists. So we can do packet filtering. This is where queuing happens of our data. We can also install firewalls. At layer 3 is a lot of times where we see firewalls. Sometimes we see firewalls up here on the edge coming into our network, but we also see firewalls here in our distribution network. We look at adding security and network policies in here. And that has to do with our access control list. This is where we see NAT happening a lot of times, network address translation, because your high-speed core network sometimes has public IP addresses because you're transferring across the public network. But internally, you have private IP addresses, so we have to do NAT somewhere. Typically, that is done at our distribution layer. Distribution aggregates typically a lot of connections down into a handful of devices. This aggregates that large wiring closet into a handful of devices. Distribution layer, layer 3 switches also stop broadcast storms. In your VLAN, we send out a broadcast to get an IP address, part of that DORA process that sends out the broadcast, and broadcasts go all the way up until the router. Well, this layer 3 switch is doing routing, so broadcast storms stop at the distribution layer. One other idea to sort of wrap your head around is at the distribution layer, when you have more than one device here, these are called switch blocks. Now, when we look at this, you can think of this area right here as almost, this is a building. This is a building. We have multiple floors, so this would be floor 1 here, floor 2, each with their own access switch, floor 3. These switches all go into a handful of switches, these layer 3 switches that do the routing, the quality of service, the security. They aggregate all these connections down into just a couple of connections that then transfer to the core. These switches right here, when there's 2 or more, these are called switch blocks. So SWITCH block. This switch block is unique to this building. And this switch block only serves the devices below it, but you need to have at least 2 distribution devices there. Finally, we have our access layer. And this is where the devices access your network. We have a voice over IP phone, we have printers, we have PCs. They all access into our network here at the access layer. These switches at the access layer, these are layer 2 switches, so they don't do any routing. But these layer 2 switches, they can have VLANs. And what these VLANs do is they keep the broadcast domain separate, because every VLAN is a separate broadcast domain. And if PC1 here is in the engineering VLAN, so engineering VLAN, PC2 is in the HR VLAN, their broadcasts won't be heard by one another because they're in separate broadcasts. So that's where we get access into our separate VLANs for our devices. As we talk about 3-tier and 2-tier designs, the question comes up is, when do I use a 2-tier? When do I use a 3-tier? A 2-tier design, like I have here in the bottom left, is typically for a single building. So this is a single building here. A single building. This single building has multiple floors. So we've got floors 2, 3, 4, 5, 6. Each one of them have their own access switch. So this is switch 2 here, switch 3, all the way up to switch 6. Each floor has their own switch. All those end devices plug into that. Then we take and we aggregate all of these switches into a single switch in the main data center in this building. This multi-layer switch, it combines the distribution and core functionalities into one device. That's where we only have 2 layers. We have the access layer, and then we have this device that does distribution and core. We can route between these different switches, between different VLANs, and we provide high-speed connectivity to our router that can then go out to the WAN or the internet. We have 2 layers. Then in our 3-tier design, this is typically done with a hub and spoke environment where you have one main building, and this is management. This is where IT is. This is where you have the big connection, the big routers, the big switches, the big multi-layer switches here. And they're concerned with getting data to the destinations as fast as possible. It connects up to multiple buildings. So our main office here is building A, but then building B, they hear that has marketing and access. They have multiple floors in their building. Each one of these floors, they have an access switch. These access switches all come down to a distribution switch. So they aggregate all of these switches together. This distribution switch then routes between VLANs, between floors, between the different departments, keeping all that data there. When it needs to, it sends data out to our core. And once again, this is our core here. And then our core can then deliver it to the other buildings. So that's building B. And then we have another building. Same exact setup. Each floor has their own access switch that's aggregated down to our distribution switch. Distribution switch handles the security, the quality of service, the routing here between VLANs, between floors, between areas, and even if we have to send data to the core to a different building. And it continues, and we continue adding in spokes here. And this is our 3-tiered design where we have access layer is separate than the distribution layer that is separate than the core layers. Networks have fundamentally changed from a flat network into this switched local area network in a hierarchical design. The switched local area network allows for additional flexibility, traffic management, quality of service, and security. And your switched LAN May also support wireless networking and other technologies as IP telephony and mobile services. It was my pleasure to provide you with this wonderful episode on hierarchical networks. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all of these episodes in video and podcast form. In the upper right is my playlist for my series on enterprise networking, security, and automation for the CCNA. Thank you so much for watching this episode of my series on enterprise networking, security, and automation for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.